Hi everybody, here's number 1 from our note packet 5.2 that I promised to do for you. We're asked to find the formula for the volume of a sphere. And if we take a look at what a sphere would look like, if I were to put a circle on our Cartesian plane, and I'm gonna go ahead and let's say we're going to take a cross section here, and if I rotate that around the x-axis, you'll notice we sort of have this circle here, if you can envision that a little bit. Now, from here to here would be x, and then this would be our y value, and the radius would be r. Okay, so by the Pythagorean theorem, we'd have this, and I need to do this with, well, I would like to do this with respect to x in this case. So I'm going to go ahead and isolate okay. Now, please remember from class, the area of our cross section is a circle, right? So in this case, and when we simplify that, then I don't need to worry about my positive or negative, because when I square that, it's going to be positive or negative no matter what. So our area of our cross section can be represented like this. So let's set up our volume. All right, now please take a look. I was able to get my bounds of negative r to r because on our circle over here, this value for x will be negative r, and the y value would be 0, true, and this value over here would be r0. That is how I got my bounds. Now, one trick you can do here is, we know that this is an even function. You don't have to do this, but if you notice from 0 to r, it's symmetrical from negative r to 0. So just watch this trick a little bit. I don't think I showed you this, but I'm going to change my boundaries from 0 to r, and just to make this a touch easier, I am going to write my integral like that. I'm going to pull out my pi, which is a constant, and then I'm going to go ahead and integrate. Then I'm going to go ahead and plug in my boundaries. And now watch what happens here. Go ahead and pause the video if you need to catch up here with the work. But when we have this over here, notice what's going to happen. We'll need to get a like denominator. And this will be 2 pi times 2r cubed over 3. And what's really neat about this one is, can you recognize this formula here? That's a volume of a sphere, right? It's a volume of a sphere. So for this next problem, they ask us to find the volume of a sphere with a radius of 1. Well, back in the day, you guys trusted that this formula was true. Now we just showed it. So all you'd have to do is plug in 1 here. And if you plug that into your calculator, you'd get about that. Hope that was helpful.